Hey guys, welcome to Teach Me Math. Today we're going to be looking at solving non-right angle triangles. I had a previous video where we used Pythagoras theorem and SOHCAHTOA to figure out the angles and sides of a right angle triangle. So now we're expanding to include non-right angle triangles. So that could be where there's no right angle, right? So you could have either an acute angle where it's all three angles are less than 90 degrees, each of them, and they add up to 180, or you could have an obtuse angle where you have one side is greater than 90 degrees and the other two are less than 90 degrees. So it really, for the following laws, it really doesn't matter if it's non-right angle or right angle. It's pretty universal, it'll work for any degree, but if it's in right angle, then you can use the ratios for SOHCAHTOA or Pythagoras theorem, but this is more of a general law. It works for anything. So the sine law is, I like to think of it as a law of proportions, really. So let's have our model here. So this is a triangle ABC. I'm going to refer to the angles by the big letters, and I'm going to refer to the sides. So these side opposite A is going to be a small a, this is going to be a small b, opposite b, and opposite angle C is going to be a small c. The sine law states that the sine of angle A over side A is equal to the sine of angle B over side B, which is equal to the sine of angle C over side C. Okay? Now, it should be pretty clear why this is the case, and because if you break it down, you already know what sine A means, right? So by strict definition, the sine of an angle is equal to the opposite over the hypotenuse, right? And so if this is the opposite side, so sine is the opposite over hypotenuse of A over the opposite, which is going to cancel out. It's going to give you a ratio which is just 1 over your hypotenuse. Whereas the sine of B over B is going to be the opposite over the hypotenuse over the opposite. So if you cancel out the opposite, you're going to end up with the hypotenuse, which is always a constant in every situation. So these ratios are always going to be equal to each other in a triangle, right? Because all that's being left is the constant hypotenuse. I hope that makes sense. Even if it doesn't, honestly, all you have to do is just remember this law. I like to think about it just because, you know, if it makes sense in my head, then it's easier to remember. But it's up to you. So using the sine law, what you have to realize is you have to know one full proportion in order to find any other angle or side. Meaning, if I give you a triangle, I give you A, okay, and I give you angle C, and I give you side B. Using this law, you're not going to be able to find anything because you're not going to be able to complete a full proportion from this, right? You're going to have, you have the sine, you have the angle A, you have the side B, and you have the angle C, but you can't use these three separate pieces of information to find anything. What you have to have, oh, that's not a B actually, sorry. Here, that's the side B. So what you have to have is a full proportion. So you have to have angle A or side A and then an angle C, and then I can fill out the rest of this thing, because what I can do is I'll have sine angle A over A, side A, is equal to sine angle C over the side C. From this, you know, isolate my unknown and then solve for it, and then I'll find my side C. And then once I found my side C, well, from this I'll know my two angles by now, and then I can use that to find my third angle B. And then once I know my third angle B, I can use the sine law and I'll find my third side B. Okay, so sine law is it's very useful, but you always have to make sure that you know one full proportion, right? One angle and its opposite side in order to find anything else in the triangle. So besides the sine law, we have one more thing called the cosine law. Now this cosine law states that a squared is equal to b squared plus c squared. This is looking awful lot like the Pythagoras theorem, but minus 2bc cosine a. Sorry. So this applies also to any type of triangle. Okay, so this is a, b, angle c, side c. So this is a squared is equal to b squared plus c squared minus 2 times b times c times cosine a. So this is one number, right? So a good way to memorize this is you're thinking, looks a lot like Pythagoras, minus 2 times these two variables, b and c, multiplied by cosine of a. Some students get a little bit confused about which angle goes here, and I always like to think it's directly associated with the side here. So if you're looking for this side, you have to put its corresponding angle in the cosine. Okay? Now, this doesn't apply just for one side. You can, you can change around the variables to mean whatever you want. So b squared is equal to a squared plus c squared minus 2ac cosine angle b, or c squared is equal to b squared plus a squared minus 2ab cosine angle c. Okay? Now in the cosine law, it's different than the sine law. It fills in the gaps that sine law has. So in my previous example, when I said that, say we don't have any full proportion, right? Say we only have this. Oh, that's still full proportion. Say we only have this. If I only have two sides and an angle, I can figure out everything else. Say I have side C, right? So I have the two sides and an angle. I can use, let's see, which one would I use? I would use this one to figure out what my side is, because I can fill in B, C, and the cosine angle A and figure out what my side A is going to be. Once I figured out my side A, then I'll have a full proportion, right? Now that I have a full proportion, I can use my sine law. Sine of A over side A is equal to any other angle, right? So this is going to be sine B, which I want to find, over the side B, which I have. And then I'll find my angle B. And then from that, I can add A and B together, subtract it from 180, and I'll find my angle C. So using sine law and cosine law together is very easy to find out what the sides and the angles of any triangle can be. All right. If you have any questions, please feel free to ask me. So if any word problems that you don't understand, please feel free to ask, and I'll try to get back to you as quick as I can.